Section 9.3, Geometric Sequences. Our objective for today is to define, identify, and apply geometric sequences. So first of all, let's figure out what a geometric sequence is. The ratio of any term to the preceding term is a constant value. You multiply each term by a constant to get to the next one. So basically, to find them, find out what that constant value is. Since it's a geometric sequence, you're going to divide the two terms that are next to each other. For instance, the third one divided by the second one divided by the first one, or whichever two in a row that you have. A geometric sequence with a starting value a and a common ratio r is a sequence of the form ar squared, ar cubed, etc. A recursive definition for the sequence has two parts. They usually name the first term, which is a, and then any term after that. So a sub n equals a sub n minus 1 times r to the n minus 1. That should be a, or no, we're on the right one. A sub n equals the previous term times r for n greater than 1. An explicit definition for the sequence is a single formula. We have the first term a, the r is the common ratio, or the relationship between two numbers side by side, to the n minus 1 for anything greater than or equal to 1. So the first few questions are going to be pretty easy. You just have to determine, is it a geometric sequence or not? If it is, what are a sub 1 and what is the r? So a sub 1 is always the easiest one to find because that's your first term, whether it's a sequence that's geometric or not. And what you're going to do is you're going to take, for instance, the second one divided by the first one and you get 2. The third one divided by the second one and you also get 2. So if you keep getting 2 throughout, it is a geometric sequence and your common ratio is 2. So 24 divided by 12 is also 2, and then 48 divided by 24 is 2. So our common ratio is 2, and our first term is 3. Okay, for the second one, our first term is 3. And we're going to take 6 divided by 3 and we get 2. 9 divided by 6 and we get 3 over 2. Since 2 does not equal 3 over 2, this one is no. So there's no common ratio. This one looks like it's harder, but really you're going to do the same thing. Sorry about that. 3 to the 5th power is your a sub 1. Your common ratio would be found by taking 3 to the 10th divided by 3 to the 5th. Remember, when you do that, you're subtracting those exponents, and you get 3 to the 5. Okay, you do that the same way for the next term, 3 to the 15 over 3 to the 10. If we subtract those exponents, we get 3 to the 5. And the last one, 3 to the 20 over 3 to the 15. We subtract the exponents and get 3 to the 5. So yes, and our common ratio is 3 to the 5. You don't need to multiply that out when it's in exponent form like that. Just leave it 3 to the 5 and that would be fine. Got it? Question number 1. Is the sequence geometric? If it is, what's the first term and what's the common ratio? Here's your first term. 4 divided by 2 would be 2. 8 divided by 4 would be 2. 16 divided by 8 would be 2. So this time our common ratio is 2. And it would be yes. The next one, our first term is 1. 5 divided by 1 would be 5. 9 divided by 5 would not be 5. So this one is no, and it's because there's no common ratio. The third one, our first term is 2 to the 3. So 2 to the 7 2 to the 7 divided by 2 to the 3 would be 2 to the 7 minus 3, or 2 to the 4. 2 to the 10 over 2 to the 7 would be 2 to the 3. And then 2 to the 15 over 2 to the 10 would be 2 to the 5. So those common ratios are all over the place. So this would also be no. And the reason, again, would be there's no common ratio. Problem number 2, what are the indicated terms of the geometric sequence? We want to find the 10th term of the geometric sequence, 4, 12, 36. So instead of finding all of them, we just want to use formulas to actually get the one we want right away. Could you find all of them? Yes, but what if you were finding the 104th term? That would take a long time listing them all out. So obviously the formulas in this case are going to do us a lot of good. And the formula that you're looking at is this one. Okay, so we want a sub 10, or the 10th term. Our first term is 4, so I'm going to substitute that in there. Okay, our common ratio we need to figure out. So our ratio is going to be 12 divided by 4, or 3. Oops, this is supposed to be 36. That's why it wasn't working. Okay, and 36 divided by 12 would also be 3. So whatever two that you do, they have to be side by side, and you're going to divide them. So we get 3, and then 10 minus 1 would be 9. So what we're calculating is 4 times 3 to the 9. Whatever that number is, that is our answer. $78,732. Now for these, I do want your formula with stuff plugged in as well as your answer. You can just do the common ratio kind of in your head. You don't have to show that unless it helps and that you want to. Part B, the second and third terms of the geometric sequence are what we're looking for. The one that we have is a sub 4, so that's the one that we're going to write the formula for because we have more information to plug into it. So a sub 4 is going to be, if we just write it out for formula's sake, we're going to do a sub 1 times r to the 4 minus 1. So let's substitute things in that we know. Our fourth term is negative 54, so we'll plug that in. Our first term is 2, we'll plug that in. Our common ratio we do not know, but we do know that 4 minus 1 is 3. So now we start to solve, so we'll divide by 2. So we get negative 27 equals r to the 3. We're going to cube root both sides to undo that third power, and our r would be negative 3. So now what we do is we go back in and we go, oh, now we need to fill in those spots that we needed to fill. So what we're doing is we're multiplying each of those things times negative 3. So this one would be 2 times negative 3, or negative 6. This one would be negative 6 times negative 3, or 18. If you keep going, it should work, you know, when you do it with the one that you had originally. So 18 times negative 3 should be negative 54, and it is. So the two that we're missing are right here. You would have to show that part right there. Okay, so anything the pink boxes are things that we need to show. Got it? Question number 2. Here we're looking for the second term of the geometric sequence. So here we are only missing one item. So by formula, here's a sub 1. We're missing a sub 2, and we have a sub 3. Okay, now there's an easier way that we're going to get to on the next page, but we'll do it by formula on this page. So the formula for a sub 3 is this. A sub 1 times r to the 3 minus 1. A sub 3 is 12, we'll substitute that in. A sub 1 is 3, we'll substitute that in, and we simplify. So we divide by 3. So we get 4 equals r squared, and we square root both sides. So r equals plus or minus 2. Be careful on this one because many people forget about those negative terms when you square root a number as well. So here's my sequence. The one that we're missing obviously is the one in the middle. Since our common ratio is plus or minus 2, this one becomes 3 times 2 as well as 3 times negative 2. So we really have plus or minus 6 in that spot. So there's 2 answers possible. And remember that 6 times 2 would be 12, and negative 6 times, or wait, okay. If we get 6 and we take it times 2, we get 12. If we take negative 6 times negative 2, we also get 12. So it does work, and we have that one that's missing. So when a ball bounces, the heights of consecutive bounces form a geometric sequence. So basically, the first bounce is going to be the tallest. Each bounce after that gets less and less and less until it stops or rolls on the ground. So here on this one, we are looking at your first term is 100. The second term we don't know. The third term is 49. So we're going to take and write a formula for the third one, which is a sub 3, a sub 1 times r to the 3 minus 1. Remember that 3 minus 1, the 3 is the third term, so that's why we subtract 1 from it. The third term is 49, so we'll substitute that in. The first term is 100, we'll substitute that in there. We will divide by 100 and square root both sides. So we're looking at the square root of 49 over 100, which is plus or minus 7 over 10. For this one, can we have a negative bounce? That's the question. So we're still square rooting this, but we cannot have the negative bounce. So we don't count it on this one because it's not just a list of numbers. It's actually dealing with something in real life. Can't have negative bounce heights. Okay, so this is why in our list we're only going to have one answer. So here it's going to be 7 over 10 times 100, which is going to give you 70 centimeters. And that should be it for that one. And we're not quite done because I didn't read the question. We want the heights of the fourth and the fifth bounces. So a sub 4 is going to be 49 times 7 over 10. And a sub 5 is going to be that answer times 7 over 10. So 49 times 7 divided by 10 is going to be 34.3. We can have decimal answers here because it is talking about real life bouncing. And then we take 34.3 times 7/10 again, which is 24.01 centimeters. So I was almost done. I just didn't read the question very well. Now, what is the height of the 6th and 10th bounces? Again, you're not that far away from getting those, so I would use the answer that I just got, 24.01 times 7/10, which is 1680.7. Okay, wait, that doesn't make sense. Okay, I didn't use a decimal. 24.01 times 7/10 is 16.8. And then a sub 7 would be 16.807 times 7/10. 11.76 is fine. So there, I probably wouldn't use formulas if it's just a couple away. If it was the 75th, I would write a formula and use it that way. One last thing. In a geometric sequence, the square of the middle term of any 3 consecutive terms equals the product of the other 2 terms. So this one is found on page 583. When you're looking at this one, the one in the middle, 18 squared, is going to equal the product of the other two. So -6 times -56 should equal the same thing as 18 squared. So 18 squared is 324, and -6 times -56 equals, okay, -6 times -56, I typed something in wrong, equals 336. I think something went wrong here. 18 squared is 324. Oh, I forgot to take a times 2. So these two multiplied. (18 squared is equal to -6 times -54. Oh, I have, okay, that's why. Because they have 54 instead of 56. That makes a big difference because then it doesn't work. So if I change that, sorry about that, you guys. Okay. So mistype right here. So 18 squared is the same as the one before it and the one after it multiplied together. In any arithmetic sequence, the middle term of any three consecutives is the arithmetic mean of the other two. So the geometric mean is the square root of x times y. The geometric mean is just the one in the middle, so we have 48. We don't know the one in the middle, and then we get 3. So if we take the square root of 48 times 3, that would be the one that we're missing. So the square root of 48 times 3, which is 12. So then if you take 48 divided by, or no, 12 divided by 48 is 0.25. 3 divided by 12 is also 0.25. If you check out the common ratio, it should be the same throughout. If you divide by 4 every time, which is kind of what it looks like the sequence is, that would be the same as well. The 9th and 11th terms are 45 and 80. As long as there's just one space in between, you take 45, you multiply it by 80, and then you square root that answer. So 60 on this one. Okay, now also when you're looking at it, I should actually go back on this one. Here we're looking at one geometric mean between this one. Whoops, oh my gosh, where did that go? I hit something with my hand. If you're looking in your book on page 583, it says, note, just before problem 4, note that the geometric mean is positive by definition. While there are 2 possible values for the missing term in the sequence, there's only one geometric mean. The geometric mean is one possible value to fill in the geometric sequence. The opposite of the geometric mean is the other. So when you're looking at it, there could be a couple of different geometric means because we are taking the square root. So on this sequence up here, we could have actually plus or minus 12 in there, depending on what that is. So got it, question number 4, we are looking at plus or minus 60. So don't forget about when you're taking the square root of that number, it could have the opposite answer as well.